Hello friends, myself is Dipali Shimpi from KK Institute of Engineering and Research, Nashik. Our today's topic is Introduction to CNC Machines and Industrial Communication. So we'll just see the introduction to CNC machines and one of the industrial communication, that is PROFIBUS. Before starting with CNC, we'll see the basic components of NC machines, that is numeric control machines. There are three main components. The first is program, that means instructions. Second is machine control unit, that is MCU, and third is machine tools, processing equipments. We'll see one by one component of NC system. The first is program of instructions. The detailed step-by-step commands that direct the actions of processing equipments. In machine tool application, the program of instruction is called part program, and the person who prepares the part program is called as a part programmer. In these applications, the individual commands refer to position of cutting tool relative to the work table on which the work part is fixed. Additional instructions are usually included, such as spindle speed, feed rate, cutting tool selection, and other functions. The program is coded on a suitable medium for submission to the machine control unit, that is MCU. The second component of NC machine is MCU, that is machine control unit. It consists of a microcomputer and related control hardware that stores the program of instructions and executes it by converting each command into mechanical actions of the processing equipment, one command at a time. The related hardware of the MCU includes components to interface with processing equipment and feedback control elements. The MCU also includes one or more reading devices for entering part programs into memory. The MCU also includes control system software, calculation algorithms, and translation software to convert the NC part program, that is numerical control part program, into usable format for the MCU. The third component of NC system is processing equipment. It performs useful work and accomplishes the processing steps to transform the starting workpiece into a completed part. Its operation is directed by MCU, which in turn is driven by instructions contained in the program part. In the most common example of NC machining, the processing equipment consists of work table and spindle as well as the motors and control to drive them. Now, we'll see about CNC, that is computer numerical control. CNC machining is a process used in the manufacturing sector that involves the use of computers to control machine tools. The tools that can be controlled in this manner include lathes, machines, routers, and grinders. Now we'll see the elements of CNC machine system. The first element of CNC system is input device. Then MCU, that is machine control unit, the machine tool, driving system, feedback devices, and the last is display unit. We'll see one by one element of CNC system. We'll see the working principle of CNC machine. Here we can see the first is input device. From this input device, the part programs will be taken and that are given to the MCU, that is machine control units. We can see here in machine control unit there are two processing units or the two units. The first is data processing unit and another is control loop unit. Here the data will be processed in this unit and the control actions will be taken from this control loop unit. Here we can see we are having the next element, that is driving system. So the motion data will be given to the driving system and which is actually taken from the control loop unit. Again, the driving system, it is connected to the machine tools. Accordingly, it will work. The miscellaneous functions are given from the control loop unit to the machine tools. Again, we need a feedback from the machine tool also. So for that, the feedback devices are used which will provide the position feedback as well as the velocity feedback, and that are again given to the control loop unit. Depending on this feedback, the actions will be taken and that again the motion data and the miscellaneous functions, that data will be applied to the driving system over here and then to the machine tools. So this is the feedback loop in which the CNC machine is working. So this is the main working principle of CNC machines. We'll see one by one element of CNC machine. So the first is one of the example, that is ball screw, which is used in CNC machine, that is a machine tool. Ball screw is a mechanical linear actuator that translates rotational motion to a linear motion with little friction. A threaded shaft provides a helical raceway for ball bearing, which act as a precision screw. The ball assembly acts as the nut, while the threaded shaft is the screw. In contrast to conventional lead screws, ball screws tend to be rather bulky due to the need to have a mechanism to recirculate the balls. The second is the feedback devices. Here, the two feedback devices can be used, like positional feedback devices and for velocity feedback devices. Some examples are given, that is for positional feedback devices, linear transducers, rotary encoders can be used. Similarly, for the velocity feedback devices, tachometer can be used. And the last is a display unit. So here, all the information, all the parameters about the product or the machine tool parameters, that will be displayed on the display unit. So the elements of CNC system we have seen, right from the input device to the display unit. So this is all about the CNC, introduction to the CNC. The next part of today's topic is industrial communication. Actually, in industrial communication, there are number of buses or protocols can be used, like device net, interbus, device networks like foundation field bus H1, HART, CAN protocol, PROFIBUS PA, control networks like control net, FF, HSC, PROFIBUS DP, Ethernet, TCP, IC. So in today's lecture, we will just see introduction to the PROFIBUS PA and PROFIBUS DP. Profibus. It is basically a process field bus. Profibus, that is process field bus, is a standard for field bus communication in automation technology and was first promoted in 1989 by BMBF, that is German Department of Education and Research, and then used by Siemens. It should not be confused with the Profinet, stands for Industrial Ethernet. Profibus is openly published as a part of IEC 61158. We will separately see what is Profibus DP and Profibus PA. Profibus DP, which is Profibus, that is process field bus decentralized peripherals. It is used to operate sensors and actuators via a centralized controller in production, that is in factory automation applications. The many standard diagnostic options in particular are focused on here. So that is what Profibus DP, decentralized peripheral. The another is Profibus PA, that is Profibus process automation. It is used to monitor measuring equipments via a process control system in process automation applications. This variant is designed for use in explosion and hazardous areas. So we'll see one small video on Profibus DP and Profibus PA.
Today, Profibus DP is one of the most commonly used networks in industrial automation. Profibus stands for Process Field Bus, and DP stands for Decentralized Peripherals. In this video, we're going to learn all about Profibus DP and what exactly it decentralizes. Imagine that we have a bunch of sensors and actuators in the field area that we want to connect to the PLC's I/O modules, which are located about 1,500 feet away in the control room. To the field area and the Imagine that we have a bunch of sensors and actuators in the field area that we want to connect to the PLC's I/O modules, which are located about 1,500 feet away in the control room. To do this, we need to connect each one of these sensors to the PLC with a separate wire. So bearing in mind the 1,500-foot distance, we're going to end up with a huge number of parallel wires, and this can increase the cost of installing the system. Now, let's see how the wiring will change when we utilize a PROFIBUS DP network. Okay, at the moment, our I/O modules are situated right next to the CPU. To use PROFIBUS DP, we can put an enclosure near the sensors in the field area and then move the I/O modules into it. Then we can connect the sensors to the I/O modules. Now, to enable data transfer between the PLC in the control room and the I/O modules in the new enclosure, we're going to install an IM, or interface module, here. Then we can use PROFIBUS DP and an RS-485 cable to transfer all data. So previously, the PLC's I/O modules were arranged centrally, but by introducing a network bus between the main controller and its I/O modules, we decentralized the I/Os, moving them to this enclosure in the field area. That's why this type of PROFIBUS has the added suffix of DP, or decentralized peripherals. We usually call these decentralized peripherals remote I/O. So using PROFIBUS DP, instead of wiring each individual sensor, actuator, or other facility to the PLC individually, we can install a set of remote I/Os next to these facilities in the field area and then transfer the data to the control area using a single RS-485 cable. This can decrease the cost of wiring dramatically, and on top of that, since the data transmission method here is digital, industrial environment noise has less of an impact on data, so data communication between the control and field areas will be more robust. But there are a number of disadvantages with PROFIBUS DP. For instance, because we are transferring data with a single cable, if it malfunctions in any way, we'll lose all the data from the field facilities. To prevent this problem, some applications have some of the main signals connected directly to the PLC and transfer the rest of the signals using PROFIBUS DP. With this wiring configuration, even if the data cable goes down for any reason, the signals from important facilities are not lost. This method is called hybrid. Another solution is to utilize PROFIBUS DP as a redundant network. In this method, we use two RS-485 cables to connect the remote I/Os to the PLC. In this configuration, if the main cable goes down, the data transfer can be switched to the reserve cable with no problems. So, to recap, PROFIBUS DP is a type of industrial network which decreases the amount of wiring required by decentralizing the PLC's I/O modules. Okay, please subscribe.